All right, factoring and review. First thing I always look for factoring is a common factor. So if I look here, 2 and v goes into both evenly. And you can always double check your answer by multiplying it to see if it matches what it was before. Here we have no common factor, so we're looking for two numbers that multiply to -4 and add to 3. So it's going to be 4 and -1, and then double check that they add to 3 and they multiply to -4, so it matches. Here I notice they all have an x in common. I should also remind you, you should try it first. Then I look and I go, okay, two numbers that multiply to -14, and the same two numbers add to -5. So -7 times 2, and then -7 plus 2, and it works, and you factored it. All right, try number 4. All right, did we match? Try number 5 first, and then see if you can make it match. It is your work matching my work, so don't just copy me. Number 6, try. And see if it's matching my work. Number 7. Number 8. So again, try to see how many you can do first and then check the answers out. This one's going to be a larger one. This is 192 and 16. I feel I need my little calculator here to help me figure this one out. I'm going to cheat. Those numbers are too big. I didn't mean to give you such big numbers to be able to do that. So I'm going to take my cheating calculator and figure out the two numbers that are going to work. I'm just going to give you the answer. I don't want you to have a headache over this. So it's -8 and 3n plus 8. That's like way too big of numbers. All right, let's try the next one. Oh, these numbers are a little bit big too. That's okay. 140 and -39. What are the... And then trying to figure out those numbers. Why did I get such big numbers? All right, I'm going to do the cheating calculator again. I don't want you to get a headache. I hope that's okay. Maybe you can figure it out before I do. Two numbers that multiply to 140 and add to -39. So that's going to be b subtract 5 and 7b take away 4. So the two numbers were 35 times 4 that did that. All right, this one we can do. Much smaller numbers. All right, number 9. First of all, you factor out an n. And then we take the first number times the last number. Think, okay, -18 and 3. So the two numbers are 6 and -3. So then I come back here and I put in 6 and -3. And then I look at the first two and I factor out a 2n and divide. Then I look at the last two and factor out a -3 and divide. And then we have our end answer. So we have n, we have n plus 3, and then 2n minus 3. A little more work involved, right? All right, let's try this one. So there's no common factor, so 3 times 21 So those two numbers are going to be 9 and 7. 9 times 7 is 63, and they add up to 16. Then I come back here and I put in 9 and 7. And then I look at the first two terms and I factor out 3v and divide. Then I look at the last two, factor out 7 and divide. And then you have your two factors. So v plus 3 and 3v plus 7. Alright, number 13. Again, these are so large, so this is what I'm going to do. I'm going to give you permission to not do 13 and 14 because the numbers are so large. I didn't know that the software I used, I didn't double check how large the numbers were that they were calculating. Okay, number 15. What do they have in common? So the biggest number is 12, and they have 3 x's, and then you divide. Oh, 12 doesn't go into that. So the biggest number is 6. And x to the 3, so 42 divided by 6 with 1x, and then negative 12 divided by 6, and you have factored it. So it's 7x minus 2. There's nothing they have in common, so it's 780. What two numbers multiply to 700 and add to 80? Such large numbers again. I guess it must be 70 and 10, right? So 70, so it's not too bad. 70 times 10, 70 plus 10, I think I figured it. So then come back here, put in 70. Oh, and you factor out an n too. Alright, so 70 and 10. And they do all have an n in common, so I factored that out in front. The first two is 7n, and then divide. The next is 10, and divide. And then you get your answer. So your answer is n, and then n plus 10, and then 7n plus 10. Alright, easier one here. This is a difference of squares, so you square root each one. So that's going to be a plus 4, a minus 4. Have you seen that one before? Number 18. Such large numbers again. This one's going to be a perfect square, so it's going to help me. But 16 quarters. Well, 8 quarters is 2. That's 400, right? So the two numbers are negative 20 and negative 20. So I also can see, because these two numbers match, that means we have one factor and it's been squared. So that one factor is going to be 4n minus 5, and it's going to be squared. So to do that, I square root and square root. Because this is negative, it's subtracting. Because these match, it creates a perfect square. All right, second page. All right, factor out 5. And then a difference of squares. So square root, 4x plus 3, 4x minus 3. I was going to sneeze. Number 20 again, square root. This again is going to be a perfect square. So 16 times 36. So the numbers are 24 and 24. So just square root and square root and then square it. As soon as you know those two numbers match, then it's a short way to do it. Difference of square. But first we're going to factor out 5, right? Again, that's 16 minus 16x minus 25 squared. So square root it, and it's 4x plus 5 and 4x subtract 5. Here we go, 4 times 1 and negative 4. So again, they match. So square root and square root and square. And it's subtracting because of the negative 4. Difference of squares, square root. Done. Factor out of 3. And then square root. Now when you square root, one's going to be positive, one's going to be negative. Just know that when you square root an exponent, you divide that exponent by 2. When you square root, you divide the exponent by 2. Here, 4 goes into 3. No, nothing goes into 32 times 18. Feels like there should be something. 2 goes in everything, right? So if I go 2, that's 16, 24, and 9. And then I know 16 times 9. So it's going to be negative 12 and negative 12. So I square root, and I square root, and then I square it. As soon as I know these numbers match, I can square root and then create a perfect square. Square root both of these, that's x squared plus 2 and x squared minus 2. Here we have 25 times 4. Again, they match, so I can square root. And I can square root. Oh, that's going to be minus because of the 20. And then square. Nothing in common. 16 times, didn't we just do 16 times 25? I felt like I just did it up there somewhere. I don't know. Alright, so 8 quarters. That's again 400, right? And 40, so it's 20 and 20. So square root, and square root, and then square. So again, we're square rooting, and then this determines the sign, and you square it. It's only when these numbers match it becomes a perfect square. 25 times 4 and 20, again, it's a perfect square, so we're going to square root, and square root, and then square it. Difference of squares, that's 4r squared minus 3 and 4r squared plus 3. Factor out of 5. And then it's a difference of squares. So it's square root 25. And 1 is just 1. And you did it. Now this is just plain old grouping where you group the first two. What do they have in common? 2p squared. That's 7p minus 3. Factor out, what do they have in common? A 7. Divide. That's 7p minus 3. So 7p subtract 3, and then 2p squared plus 7. Again, press pause and try these. Factor out of b squared. Factor this, there's nothing, so you have to factor out a 1. So 1 is 3b plus 5, and then b squared plus 1. Try it. All right, don't give up. Keep trying. Are you able to do any of these first? That's the goal, right? I'm doing the work so you can see that you did it right, not to copy my work. Try it. Press pause. Alright, what do you think? Did you match it? Press pause. Let's try this one before I do it. Alright, 2 left. Press pause, see if you can do the last 2, practice it. You really have to know your timetables. Alright, last one. Press pause, see if you can do it. All right, we got there. Mr. G Math over and out. Good job getting your work done.